Welcome Satoru, and thank you for joining me in this conversation. I'm Fabrizio BARPI, Professor of Structural Mechanics at Politecnico di Torino, Department of Structural, Geotechnical and Building Engineering. And so please, Satoru, if you want to introduce yourself and the center you are working. Thanks. Thank you for joining us.
Thank you very much. So, my name is Satoru Yamaguchi. So, belong to the National Research Institute for Earth Science and to Disaster Resilience. So our institute studies natural disaster phenomena that occurred in Japan, such as earthquake, tsunami, volcanic eruption, heavy snowfall, flood, and snow disasters. And my subject is snow disaster, especially for the snow mechanics, physical mechanics. And also, I have studied the avalanche generation mechanisms.
We started our cooperation because on one side in Nagaoka there is a very important center about avalanches. So Satoru is working, is a chief researcher on a research center with a facility where it's possible to obtain artificial snow. There are a couple of cold rooms where we can test snow, and we can test snow specimen at, let's say, minus 10 degrees. It's also possible to store snow, and so it's possible to do very nice experience. So if you want to add something about your facilities that are, for us, very important in order to go ahead with our cooperation.
Yes, so you know that half of Japan is covered with the snow, and the avalanche research is very important in Japan. So, but unfortunately, we don't have enough knowledge of the avalanche. So the cold room experiment using the good device is a key point to develop the numerical model for forecasting the avalanche. But unfortunately, we have a lot of the cold room, but so we don't have the good technique to develop the device to measure the snow physical.
Okay, the key point of our cooperation is related that we developed, we and some colleagues at Politecnico Torino, a sort of experimental device that led possible to test snow specimen and measure the shear strength of snow, and in particular the shear strength of, let's say, the interface between snow and ground that is the object of our experiments. So we start in Politecnico di Torino from the classical manual shear frame. You can see many different pictures of books related to avalanches, but we develop a sort of device where it's possible to apply a sort of set of control conditions. So we can test snow, we can apply normal pressure to, let's say, simulate the amount of the snow that is covering a specific point, a specific specimen, and so everything is controlled in such a way we can do experiments we can repeat many times, and we can also use this device in situ condition. So in the cold rooms of the Snow Research Center in Nagaoka, it was possible to do some tests, I want to say a lot of tests in different conditions, different normal pressure, different temperatures, and different snow conditions, thanks to the fact that it's possible to build different snow specimens. And so the idea was to measure, as far as we can, the mechanical properties of the snowpack that are very important in order to do some sort of, forecast about avalanche hazard and so far. And so that was the core of our cooperation.
Yes, so our knowledge should be very important for improving the conventional numerical model, in which usually don't consider such a detailed snow properties. So if we use our knowledge, if we can introduce our knowledge to the conventional numerical model, I believe so we can, the accuracy of the avalanche forecasting should be increasing.
Yes, it's also important in Italy because as in Japan we have many problems related to snow avalanches. You know, the weather is changing, and so we are facing new problems about this particular avalanche hazard. And so we hope that working together with our Japanese colleagues in a cold room in some sort of controlled condition, we can get some new insight for you know, avalanche prediction, avalanche triggering, and so far. It's also important to study the triggering of avalanches in order to use these results in numerical models for avalanche dynamics. That is another, again, important in order to do some sort of forecasting.
Avalanche condition changing due to the climate change. That means the global warming. For example, the wet snow avalanche occurred even though in the middle winter. The conventional model cannot be forecast such a avalanche under the changing the climate conditions. So we need a more sophisticated models. So our collaboration is very important for such a improvement.
On the other hand, we hope that the results we have found, we have done a common publication on this subject. It is another important aspect to spread the knowledge that we obtain together, and we hope that these models can be also used for you know, numerical models, avalanche prediction, avalanche dynamics, and so far. Another aspect we hope we can do in the future is go ahead with our cooperation. Another point is that is particularly important in Japan is the field of let's say earthquake-triggered avalanches that I know are quite important in Japan. So if you want to add something about this, this particular problem.
Not only Japan, but also your country, maybe. So
Yes,
we have a lot of the
yes.
earthquake.
Yeah, exactly.
In winter, we have the earthquake in winter. The avalanche occurred by triggering of the earthquake. But we cannot predict such a avalanche caused by the earthquake because the mechanism is different from such avalanche and normal avalanche. So based on our result, maybe give us some clue to understanding such a normal avalanches.
Yes, it is a possible problem, problem we can examine together in the future, because we can try to do experiment with different, you know, loading rates, and so maybe we can get some new insight about this particular problem. On the other hand, there are many things we can do together in some sort of possible future cooperation. One is to go again in your laboratory, and we want to improve our device. You remember that we have found many problems. Some of them were solved, others not, and so one idea can be in the future to go in laboratory and to do other tests to improve the mechanical knowledge of snow, and also to improve our device. Another point that is a little bit a sort of a dream is to use our device in situ, so to go in some sort of slope and to measure some mechanical properties of weak layer that is very important for triggering avalanches, and so is another possible cooperation. On the other hand, we can just try to build some sort of database about the mechanical properties of snow that, in our opinion, can be quite important, and maybe we hope in the future we can share some PhD students, so we can hope to do some research about possible common interesting problems by some new PhD students, and maybe, who knows, we can also do some we can apply for some international, you know, competition to get some funds in order to go ahead with our cooperation. That's what I hope for the future.
Yes, so so we will start a new research project since last year. I think that this timing is very good for improve the collaborations, and so in our opinion, so we will focus on the snow property from the microstructure view, from the view of the microstructure. So if we can use your good device, very helpful to understanding the such a snow futures.
Okay, I hope we can do in the future, and so we will work in order to do this, as soon as we can. So we are basically at the end, and what I want to do is to thank you again, to thank all our friends that cooperate with us in Japan and also in Italy. So thank you again for joining us, and we will see somewhere, maybe in Nagaoka in the future. Thank you very much.
Thank you very much. So it's our pleasure to have more collaboration with your site.